As I tried to emphasize in the philosophy of language, philosophy of science, and epistemology episodes, language word games and the meaning of such words as truth and knowledge are not static but dynamic and constantly changing. Knowledge is a fabric of intertwined truths. This is even true of science and its language and methodology. There is now occurring a material change in the language of science and the scientific method through the development of what is called data science. As discussed in prior episodes, the scientific method is a technique with four attributes: hypotheses that can be tested through repeatable, falsifiable, and parameter-controlled experiments. Data science is changing this technique by eliminating the hypotheses attribute to replace it by algorithms that discover correlations in massive amounts of facts or data that are simply beyond the ability of human consciousness to synthesize into hypotheses. A basic explanation of what is happening is contained in an article in the online magazine Wired entitled The End of Theory, for which I have added a link to that article on our Philosophy of Science webpage. Essentially, what is happening is that the available facts and data available for scientific study is simply too large for direct comprehension by human reason. One of the modern world's most creative techniques for dealing with the paradoxes of reason and the convoluted complexity of the universe in order to continue seeking predictive knowledge is the language of statistical and probabilistic analysis. The history of statistics in Western civilization begins with the historian Tyclocrates in his History of the Peloponnesian War, where he describes how the Athenians used a sample portion of a fortification to estimate the strength of the fortification, and then this statistical study explodes exponentially in the modern world with the age of science. In the last couple of centuries, statistics and probability have gone through an enormous amount of theory, varying from the development of relatively simple math necessary to calculate life tables for governments and insurance companies, to the modern Bayesian statistics and its battles with frequentness, and onto its progeny, data science, that successfully uses applied mathematics to create algorithms to find correlations in massive amounts of data without any hypothesis nor any explanation linking of that data or explaining that data in any way. For most of the modern era, the world has had two models of scientific explanation. One, the deductive homological model, using mathematical general laws and principles to give deductive universal relationships that usually but not always give a cause and effect explanation. And two, the probabilistic statistical model, using mathematical general laws and principles to give inductive specific relationships. The first model suffers both the logical problems of cause and effect and the paradoxes of induction contemplated in earlier episodes of this podcast series. The second one need not worry about cause and effect, but still suffers from the paradoxes of induction. In the post-World War II era, scientific methodology proceeded into new areas and problems with new sciences such as genetics and both quantum and relativity physics that established both models to not only overlap, but often to fail to explain scientific success. Thus, the paradoxes of induction and cause and effect, and the skepticism they paradoxically caused, once again took over, leading such philosophers of science as Paul Feyerabend to assert, quotation, "Science is essentially an archaic enterprise. Theoretical anarchism is more humanitarian and more likely to encourage progress than its law and order alternatives." Close quotation. Now, some in the progeny of statistics and probability called data science entered the epistemic fight by claiming a further model of scientific explanation. No explanation. Quotation, "Correlation is enough." Close quotation. This should actually sound great to anyone interested in logical and rational thought, because there is no cause and effect fiction necessary to make the reasoning dishonest and paradoxical. Also, there is no induction paradox we must dishonestly ignore in order to pretend we have a universal explanation. All there is data, algorithms, and resulting mathematical correlations that are useful for predicting the future and thus can be tested in parameter-controlled, repeatable, falsifiable experiments and thus are true until they are wrong, just like all other models of science. As described by the Wired article, for which I have a link on the web page, this data science is working as well as, and even better than other scientific reasoning, in areas varying from advertising and biology to quantum physics and zoology. Correlation without explanation and without hypotheses is given predictive value that can be tested and falsified in parameter-controlled, repeatable experiments to areas whose immense amount of data and information is simply not susceptible to the limitations of the human mind's ability to satisfy Occam's razor. Correlation is now the satisfaction of Occam's razor. Data science is a perfect example of Wittgenstein's form of life development of scientific language, or of a scientific word game. However, it has many critics who deny that it is science, nor a scientific word game and a scientific method. With no cause and effect and no induction paradoxes, correlation is an honest and logical satisfaction of the most basic attribute of the word game that is science, that being predictive meaning and value. So what is the problem? Why does it have so many critics that deny it is a scientific word game? We'll consider that in the next episode.